Right, we are back with some quick math. We are looking at some functions. Today, specifically, we will do the quadratic function, the parabola. Okay, so the general equation of your parabola or your quadratic function will say f of x, and that will equal to ax squared plus b of x plus c. I want to make that a nice x plus c. Okay, so you have this form of the quadratic function, and this is your quadratic form. Okay, so this over here is a parabola. You also have the form, we can keep it f of x, which looks like this: a open bracket x minus p close bracket squared plus q. This we call the turning point form, just because if you have it in that form, then you know p and q would be your turning point. Yep, so that's very nice. There is another form which you will need to know. It is the intercept form. So that one looks like this: a x minus x1 and x minus x2. And in that one, that's what you would use if you have your two x-intercepts and you want to find the equation of your function. So all three of these are parabolas. All three of these you will use. Okay, let's maybe discuss the very first one. Okay, so let's get rid of some of these other ones. Okay, let's discuss this first one. When you have this, okay, or maybe let me just mention this quickly before we move on. All three of these a values are the same. Okay, so you should already know what a does to your function, but all three of those a values do the same thing. They're all the same value, right? When you manipulate any of these formula, a is the same thing, okay, throughout. Great, let's maybe mention this as well. So a, what does a tell you about your function? You know, if a is positive, then your function would be, let's go with a happy face. Okay, if a is negative, your function would be a sad face. Okay, so that's something that a tells us. In this equation, b and c, well, b, for example, doesn't really tell us anything. Okay, it will help us find some stuff, but b doesn't tell us anything. C, our c value over here will give us our y-intercept. So c will be your y-intercept, or your y value of your y-intercept, because I know a y-intercept is a coordinate, y value of your y-intercept. Okay, because you know, in order to find your y-intercept, to make x 0, so if x is 0, this becomes 0, this becomes 0, you're only left with c. Okay, so those are things that you can see just from the equation. You know what a is, you know what c is. A is going to tell you happy face, sad face. C will tell you your y value of your y-intercept. When you do have this form of the equation, then you know you can also use this equation: x equals minus b over 2a. Okay, I'll make another video where I show where we find this. But when you do have your quadratic form, which is the form that we have above, you can use this formula. And what is this formula for? Make sure you understand what this one is for. This is for the x value of your turning point. Okay, so when do you use that formula? When you've got your quadratic form and you want to find the x value of your turning point. Now, in order to find your y value of your turning point, there is an equation. I'm not going to introduce it to us here. I'm not going to even speak about it, because once you have your x value of your turning point, in order to find your y value of your turning point, you will just take your x value and substitute it back into your function, and that will give you your y value. Okay? So I'm going to leave you with that. So what I'm telling you is this: if you have your quadratic form, right, which we have over here, then your c value is your y-intercept. To find your turning point, you go with this. In order for you to find your x-intercepts, okay, so remember, whenever you draw a function, you always need to show me all intercepts. So x-intercepts, y-intercepts need to be shown, and your turning point. So turning point we've discussed is over here. Y-intercept we've discussed is over there. Your x-intercepts. How do you find x-intercepts? By making y 0, right? So we know that the whole f of x is our y. We think of it as y. So in order to find your x-intercept, you say 0 is equal to ax squared plus bx plus c. So then you will factorize this, and once you factorize it, that will give you your two values of you, which are your x-intercept. 2, if you have 2, you could have 1, you could have 0. Okay, so if it's not factorizable, if you can't factorize it, if your calculator ends up giving you math error, then you know that there's no x-intercept. But we'll maybe talk about how that looks in a different video. Okay, so what am I telling you? What I'm telling you is this: in order to draw your quadratic function, you need to give me three things: x-intercept, y-intercept, turning points. Well, turning point. In order to get your x-intercepts, quadratic formula, quadratic function, right? So you go to that, you factorize it. If you can't factorize it, quadratic formula. I'll put that on there in a second as well. In order to find your y-intercept, your c value. In order to find your turning point, this equation, but you must have it in the form ax squared bx plus c in order to use this. Okay, once you have that, you take this value, you put it back in that equation in order to find y. Once you have those three things, you can draw your function for me. Okay, so I did mention that if you can't factorize this, you need a quadratic formula. So just a reminder, what is the quadratic formula? It is x is equal to minus b plus minus the square root b squared minus 4ac over 2a. So you use your quadratic formula in order to find your x-intercepts when it is in this form. Great.